Hello, my name is Nuralia Azdisha and I will be presenting slab 2. This is the characteristic actions and materials. This slab is one-way slab. For slab thickness, minimum thickness for fire resistant is 80 mm. Then I got H 49.2 mm and I'll be using H 100 mm. And for durability, fire and bond requirements, C min B 10 mm, C min durability 15 mm, A 20 mm, C minimum 15 mm, and C nominal equals to 25 mm. Then for design action, I've got 8.21 kN, and this is the analysis. F equals to 10.1 kN. For main reinforcement, D equals to 70 mm. Then first interior support, I've got A is for 36.99, near middle of span 32.15, and at outer support 70.28. For shear, I've got VED 6.06 kN, VRCD 26.77 kN, V minimum 337.69 kN. So VRCD I've got 26.77 kN, which bigger than VED, and it means it was safe to use. For deflection, modification factor for steel area provided, I've got 7.08 and it was bigger than 1.5. For allowable effective depth, I've got 730 and 02. For actual effective depth, I've got 70.57, which is lower than the allowable, and it means it was safe to use. For cracking, both main bar and secondary bar was safe to use.
Good morning to Sir. My name is Mashilia Wadiha binti Abdullah, 07 DKA 23 F1106. Today I will be presenting the structural design for beam 2. First, let's look at the basic information. The slab thickness is 100 mm. The unit weight of concrete is 25 kilonewtons per cubic meter. And the weight of brickwork is 2.6 kilonewtons per square meter. For the characteristic actions, the permanent load excluding sulfate is 1.3 kN per meter. The variable load is 2.5 kilonewton per meter. The design life is 50 years. Fire resistance is R60 and the exposure class is XC1. Next, the material properties. The concrete has a characteristic strength of 30 MPa and the steel reinforcement has a yield strength of 500 MPa. The nominal concrete cover is 30 mm and the assumed bar diameters are 25 mm for main bars, 12 mm for secondary bars, and 6 mm for links. This beam is designed specifically for segment E122. This slide shows the geometry of the T-beam. The web width BW is 250 mm. The flange thickness HF is 100 mm and the overall depth H is 600 mm. Using the distance between adjacent beam, the calculated effective flange widths are B effective I equals to 676 mm, B effective 1 583 mm, B effective 2 403 mm. After combining these values, the final effective flange width adopted in the design is 1236 mm. This ensures the beam behaves as a T-beam with sufficient compression area in the slab. Now moving to shear and bending design, the shear force is calculated using V equals to W times L over 2. V V equals to 65.8 kilonewtons. The maximum bending moment is M equals to W times L square over 8 equals to 55.6 kilonewtons meter. The effective depth of beam is 451.5 millimeters and the lever arm is taken as 0.99D. From these values, the required steel area is 289 square millimeters. The minimum is 169 square millimeters and the maximum allowable is 5,000 square millimeters. So our design falls within the acceptable range. The design shear force VED remains 65.8 kilonewtons, confirming the beam is safe in shear. From the structural analysis, the uniformly distributed load on the beam is calculated to be 38.1 kilonewtons per meter, with an effective span of 3.38 meters. Using this load, the minimum shear capacity required is 100 kilonewtons. The required steel area, AS, is 189 square millimeters, and for that we adopt 2H16 bars giving 201 square millimeters, which is sufficient. Next is the deflection check. The allowable span to depth ratio is 34.2 times 0.8 times 1.0 times 1.14 equals to 31.2. The actual ratio is 3,380 over 451.5 equals to 7.5. Since 7.5 is less than 31.2, the beam satisfies the deflection requirement. For cracking, the steel stress is 258 Newton per millimeter and the bar spacing is 74 millimeters, which is below the limit of 100 millimeters. So cracking is also acceptable.
My name is Nasha Zoni binti Fazli and my matrix number is 07DK823F1082. Now I'm going to present about column 2. Given permanent design action GK 1.30. For variable design action QK is 2.5. Characteristic strength of concrete FCK is 30. However, characteristic strength of steel FYK is 500. So this is our dimension for column 2. As you can see here, we choose B multiply H is 270 multiply 350. And as you can see, the length for first floor to roof is 4m, and length ground floor to first floor is 5m, and the length footing to ground floor is 1.50. And for the beam, as you can see here too, the length for 1 to 2, 3.338, and length to 2 to 3 is 1.23. And the length for A to B, 3530, and length for B to C is 3.43. So this is the beam for 2 AC and the beam for bow 1/4. So the design action WD that we got for roof is 5.51, first floor is 5.512, and ground floor we got 5.51. Axial force on column B2. For first floor to roof, the action from beam that we got is 19 kN. Action from beam B14 is 13 kN. Column self-weight that we got is 13 kN, and the column axial force that we got is 45 kN. Now is ground floor to first floor. Action from upper column we got is 45 kN. Action from beam 2AC, we got 19 kN. Action from beam B14, we got 13 kN. Column self-weight that we got is 16 kN, and column axial force ground floor to first floor is 48 kN. Next is footing to ground floor. Action from upper column, we got 48 kN. Action from beam 2 BC, 19 kN. Action from beam B14, 13 kN. And column self-weight that we got is 4.78. And lastly, column axial force for footing, we got 84.78. That's all. Thank you.